Okay, guys, so welcome back to our class today, and we are going to be considering the topic projectiles. Now, under projectile, we are simply going to be looking at what is projectile and some examples of projectile motion and their applications. And then we talk about the horizontal and vertical component of projection. And then under that, we'll now explain the difference that exists between the time of flight of a projectile, the maximum height, and then the range of a projectile. So, in order to begin this class, I'd like to define what projectile is. So, projectile can be defined as an object thrown into the air or launched into space that moves freely by itself under the influence of gravity and air resistance. You could also say that it is an object whose curved motion in space is affected or influenced by gravity alone. Now, by defining this, I'm trying to say that whenever you release a stone from a catapult, what happens is that you have launched that particular stone into space. However, while it is moving freely, there are some forces that act on it. So those forces are forces of gravity, and then we talk about air resistance. So basically, we refer to these forces as forces that affect or influence a projectile: air resistance and the effect or the influence of gravity. Now, it is also important for us to note that the path that is followed by a projectile is referred as a trajectory. A trajectory is the path followed by a projectile. It's usually a parabola, a curved path. In my second definition, I called it a curved path. It's parabolic in nature, but it is called a trajectory. Now, some examples of projectile are as follows. I've mentioned one of them, a stone that is released from a catapult. Also, when you fire a bullet from a gun, that bullet is also referred to as a projectile. Whenever an athlete does the high jump, it follows also that particular athlete is also a projectile in that case. A thrown rubber ball bouncing from a wall is a projectile. A kicked football in the air, a thrown javelin, and a missile. All of these are projectiles. There are so many other examples that are projectiles, examples of projectile. However, I can categorize these examples into applications. Majorly, projectile has its application in warfare and in sports. So some of these examples that I mentioned now are some of the applications of projectile in warfare, and some of them are also some of the applications of projectile in sports. In sports, all the kicking of ball, a high jumper, a thrown javelin, and shot put, discus, all of those are sport-like kind of projectile. While in warfare, when you throw a bomb, when you want to fire a gun or a bullet from a gun, or you want to throw a missile, all of these are applications of projectiles in warfare. Now, in warfare, once you know the distance from an army camp to an enemy position, maybe in the Nigerian setting like the Sambisa forest or any form of enemy hideout, the angle of projection that is required for the missile to hit the enemy target can be calculated. I will show you briefly the equation that you can use to calculate that angle of elevation. And once you calculate that angle, the nozzle of the gun or the rocket launcher is then set accordingly in order to release or fire the missile to land specifically in the place that is being targeted. So these are some of the ideas of projectile in warfare, and I'm going to be showing you how that you can be able to deduce that from your understanding of vectors. Whenever a vector is resolved, it is being resolved into the vertical component and the horizontal component. Now, from the diagram you're seeing, you can see that the velocity v of the projectile can be resolved both to the vertical component and to the horizontal component. Now, when we resolve it to the horizontal component, the velocity is resolved to be u cos theta. Resolving resolving a vector to the horizontal component, you resolve it using cos theta. And whenever you resolve a vector to the vertical component, you resolve it with sine theta. So the horizontal component for this velocity is u cos theta, and then the vertical component of the velocity is u sine theta. But it's important for us to also know that the horizontal component is not affected by the acceleration of free fall. So it means that it remains constant. No kind of force is acting on the x direction. The only force that is acting on the vertical component or the y-axis. Now, once the velocity gets to the maximum height, it takes a little rest there before starting to return back to the projection plane. So it means that at the maximum height, that the speed or the velocity v is equal to 0. So now, using the equation of motion, when a body is projected at a certain angle to the horizontal, we can be able to deduce the time it takes that particular body to get to its maximum height. So making use of v is equal to u plus at. Once the body is accelerating upwards, since we know that the vertical component, the velocity towards the vertical component is u sine theta, if we substitute this accordingly into the equation of motion, we are going to get that vy is equal to u sine theta minus gt. That is when it's moving upwards, and then u sine theta plus gt when it is moving downwards. So if we eventually work out this and make t subject formula, we are going to get that t is equal to u sine theta all over g. Now, this time is the time it takes that particular body to get to its maximum height. So it means that anytime we want to calculate the time it takes a body to get to its maximum height, we use the formula small t is equal to u sine theta all over g. Please take note of this particular formula. It is going to be important for you in your examination. So the implication of that is that since the time taken to rise from the ground level to the maximum height is equal to the time to fall from the maximum height to the ground level, we can also now say that the total time, or what we call the total time of light, which is the time it takes it to go to the maximum height and return back to the projection plane, is 2 times the time that we mentioned earlier. So the capital T is the time of light, that is the total time of light, and the small t is the time it takes it to get to the maximum height. And since it's double the time to get to the total time, it means that we're going to have 2 times u sine theta all over g. So that implies that the total time of light, which is the time it takes or required for a projectile to return to the same level from which it was projected, can now be deduced using 2u sine theta all over. All right, so in order for us to calculate or deduce the total height, or what we call the maximum height in which a projectile will get to after being projected, we are going to deduce that by deriving it from the equation of motion v squared is equal to u squared plus 2s. Now, I'd already said that at maximum height that the velocity is equal to 0. And since the vertical component of the velocity is u sine theta, so, and then when a body is moving against gravity, acceleration due to gravity g is minus. If I substitute all these values into this equation I mentioned before, I'm going to derive a formula h equal to, that's the maximum height now, h is equal to u squared sine squared theta all over 2g. Now, it means that the maximum height, which is the highest vertical distance that is attained from the horizontal projection plane, can be deduced using this formula. So whenever a body is projected at a given angle theta that is not equal to 90, we use the equation u squared sine squared theta all over 2g. But whenever it is projected with an angle that is equal to 90, that is when it is said to have been projected vertically, then we can use u squared all over 2g. Then finally, we have the range. Now, the range is actually a term that describes the horizontal distance from the point of projection to the point where the projectile hits the projection plane again. So if I throw a stone from my position, any point where that stone lands to the projection plane again is the distance from the point of projection to that point is referred to as the range, the horizontal range. Now, we know that speed is equal to distance over time. And this distance in this case is the range. So if we make distance the subject of the formula, what we are going to get is that the distance, which is the range in this case, is equal to the speed times the time. And the speed in this case, which I mentioned earlier, is for the horizontal component, which is equal to u cos theta, which is u cos theta times the time. So the distance range, the horizontal distance range is equal to the horizontal component of speed or velocity times the time. And we had already mentioned that the time in this case is the maximum or the total time of flight, which is the time it takes it to land to its projection plane. And we had derived that the time of flight is 2u sine theta all over g. So if we combine this together, we are going to get that the range is equal to 2u squared sine theta cos theta. And from trigonometry, we can equate that to be equal to sine 2 theta. So substituting that accordingly, it means that the range can be deduced using u squared sine 2 theta all over g. So what that tells us is that maximum range could be attained whenever theta is equal to 45 degrees, because 2 times 45 will give you 90, and you know that sine 90 is equal to 1. So anytime theta is equal to 45, it means that we are going to get our maximum range. So at maximum range, it means now that our formula will be equal to u squared all. In the case where a body is projected horizontally from a certain height that is above the ground, the same principle will take place. We still have our horizontal component or motion and then the vertical motion. I'd already mentioned earlier that the horizontal motion is the range is equal to ut. So we'll use that also to calculate the horizontal motion or the range. However, in this case, the vertical motion would be able to calculate the time. Now, the time of flight in this case now, because it did not start from the projection plane, it started from a height, a certain height. Now, the time of flight now will be different. The time of projection will be different. So using the formula S is equal to ut plus half at squared, if I substitute the values that I have, I will get that the time it will take the body to land to the projection plane could be equal to square root of 2h all over g. Now, this time is the time taken to reach the ground or the foot of the particular height that is being referred to. And it is quite different from the other times that I've referred to. The time to get to the maximum height and the time of flight. This one is a little bit different from them. This one is for the time a body takes to land to the projection plane when it is released from a certain height. So having said that, I'm just going to quickly test you to see how much you understand everything I've said, and we're going to solve a question together, and then I'll give you some revision questions that you're going to go through. Now, for us to attempt is this question: a projectile is fired from the ground level with a velocity of 500 meters per second at 30 degrees to the horizontal. Now, determine the horizontal range and the greatest height attained. Now, this greatest height attained is also the maximum height. Now, you can pause the video and try to solve this question yourself before I'll show you what the answer looks like. I believe that you have applied the formula that I mentioned earlier to solve. So if you've gotten it, here is my own solution. You can compare your answer and check whether you are accurate. Now, please take note that the angle that you're meant to use for this solution is the angle to the horizontal. So sometimes examiners can test you by giving you the angle to the vertical. So it means that anytime a question comes with an angle to the vertical, you have to find the complement of that angle. For example, if they say the angle to the vertical is 30, since what we need is the angle to the horizontal, it means the complement of 30 is 60, and that is the one you're meant to use. If not, your answer will be wrong. So take note of that. It is important. Now, I believe that it has been of help to you. Please take time to go through it again, and then I'll be asking you some questions that will follow suit. So stay tuned and